Okay, guys. I'm picking up in lesson 4.4, day 3, final day. Now, I forget, have I been turning the lights off in here?
Yes.
Okay, as I know that kind of helps with glare from my virtual. If you guys can handle it being present, it makes life a little bit better. Okay, while I was tackling attendance, I asked you guys, we did A and B yesterday on example 3. I asked you guys to try C and possibly D. I don't know that I'm going to take time to go through both of them, because we did 2 yesterday, but I'd like to at least go through one of them and remind you of what we did yesterday. Make sense? Because I know you slept, it's been a whole 24 hours. We may not remember what we did yesterday. Okay. So, let's look at C. Okay. I don't know if you guys started this way, but first question to yourself that technically you should be asking yourself, is there a greatest common factor? You guys may have skipped that step, but it's always good to think about. Is there a greatest common factor, GCF?
No.
There is not. Now, can I go ahead and just jump to 2 parentheses? No, because it's not just a 1x squared. There's an a value. When there's an a value, we need to think about what I called product of AC. So when we talk product of AC, what are my A and C here? 4 for ax squared, and plus c is 3. So 4 times 3, a product of 12, and a sum of our b value still, which is the middle value of 7. Okay, I think we did product of 12 just yesterday, didn't we? 1 and 12, 2 and 6, 3 and 4. Which pair multiplies to be 12 and adds to be 7? 3 and 4. Good news is, multiplies to be positive 12, adds to be positive 7, so they are both positives. What do I do with that 3 and 4 now that I have it? Do I just put it in parentheses and call it done?
No, you've got to split up the 7x.
Okay, we're going to split that middle term. So we're going to split the 7x. And we're going to split it into 3x and 4x. So you have 2 options. You can either say plus 3x plus 4x, or you can either say plus 4x plus 3x. It works both ways. Some of you don't believe me on that, but it does work both ways. Which way did you guys do it? Curiosity.
Plus 4x
Plus 4x plus 3x?
I did 3x.
Okay.
I did that first and then
Didn't like how. Okay, so here's my thought. Those of you that did 4x and 3x, I think you probably went the slightly easier route. And that's good. And this is where I say, as you get better at this, you'll start picking and choosing, ooh, I'd rather see 4x and 3x as opposed to the other way around. Because in the advantage of doing 4x and 3x, 4x squared and 4x will have a GCF, a nice one of 4x. And then 3x and 3 will have the 3. And so it'll make life a little bit easier. Now, does that mean it's impossible to do it the other way? It doesn't. And I kind of want to go the other way just to kind of show you the option of the fact that if, like I think Abby, you said you tried 3x and 4x and you got kind of stuck and backed up, which is good. I'm going to put it as 3x plus 4x. And I guess I'm just kind of doing that to show you that it is possible. Okay? Is there a question I can answer, Eli?
Yeah, are we trying to find like things that will add up to 7 that have greatest common factors with the 2 on the outside? Or what are we looking for?
It was numbers that multiply to be 12. So product of AC. So whatever 4 times 3 is, which is 12. So it's a product of 12 and a sum of 7. And that pair is 3 and 4. So then you take that pair of numbers and you're going to split the middle term with it in either order. And that's what I was just talking about there.
Okay. See, I just guess I point that out.
Okay. Yeah, make sure you're focused on this problem with us. Because, okay, so we split the middle term. What about the first and the last term? You keep them, they carry down. Okay. So now, the whole point is that I have 4 terms. What do you do when you have 4 terms? Split it in half. So I'm going to split it in half. So it's 2 and 2. So I'm splitting it in half right after the second term. And so like what I was doing yesterday is I'd kind of cover up the back half. And I'd say, okay, what's the GCF of the first half? So what's the GCF between 4x squared and 3x?
1x.
Okay, 1x. Oftentimes there's a number in common, right? And if you put 4x first, you'd have 4x. But since I just put 3x first, there's just an x in common, and that's okay. So that means I'm going to divide both of those terms by x. So I'm going to put the x out front, and then I'm going to have parentheses. 4x squared divided by x leaves me with 4x, just cancels an x. 3x divided by x leaves me with plus 3. Now, uncover the second half and repeat the process. So now I'm looking for what is the GCF between 4x and 3. This might be where Abby said, I don't know, I quit. Okay? If all else fails, and there is, I hate to say the word no GCF, what's the default answer? Always 1. Okay, so there's no x in common, I get it. There's no other factor, bigger factor than 1. So we're going to factor out a 1, which means, yes, officially, I'm dividing both of those pieces by 1. Even more importantly, yes, you need to write plus 1 as the GCF I'm factoring out. And then I start my parenthesis. What's 4x divided by 1? 4x. Plus 3 divided by 1? 3.
If you did it the other way, the x plus 1 would be in the parentheses.
Yep.
And the 4x.
Yeah, okay, so and this is kind of a good example of C because I know sitting here in class, a lot of you did go the other way. And so if you went the other way, your x plus 1s are in parentheses, and your 4x and plus 3 are your GCFs. Okay, either way we went, here's the good news. Do my parentheses match each other?
Yes.
Yes. So now, don't forget to write your final answer. One set of your parentheses is your matching parenthesis. My matching parenthesis is 4x plus 3. The other set of parentheses is your GCFs. Mine was x plus 1. So that's kind of why I wanted you guys to work ahead and try it, because I wanted you guys to be able to see the 2 different options here. Okay. Are we okay with that technique for the most part? Did some of you do D?
Yeah.
I'm not going to take the time to go through it unless you really want me to, because I'd rather focus on some of the other stuff and maybe get you some work time at the end. But what you guys get is your answer on D.
One parentheses, I got x minus 2, and then I got 2x minus 4.
Yep. If you did this problem, it is x minus 2 times 2x minus 3. Okay? If you didn't do that problem, whatever. But, you know. Yes?
So, in this one, it's not D, it's C. We got lucky 4x plus 3 are the same in both parentheses. What happens if you get different?
If you get different, if your 4x plus 3s came up different parentheses, you made a mistake.
Got it.
They will come up the same, or you have made a mistake.
Every time you do a problem like this, they all
Yes. That's the design of the problem, because it's factoring by grouping. And so when you group into 2 groups and you factor it, they work out to have the same parentheses.
Okay. See, I had to make sure.
Yep. And that's part of what I explained yesterday, and I don't always remember to say everything the second time around. So, yep, you got it. Okay, now, E and F, I want to go through. E and F can be done the exact way you just did the previous ones. However, they are also special cases, and so we can also do a slightly different option here. Okay, so you can, on E and F, still do product of AC. No problem. However, I'm going to show you a slightly different technique that if you catch it, it's good to use. Now, my first question is still always what?
What's the GCF?
Is there GCF? So on E, is there GCF? Oh, there is, so we should use it, right? Okay. Let's divide everybody by 4. Now, when I divide everybody by 4, don't forget to write the 4 out front.
Okay, so when
Okay, well, I guess whatever that question was. Okay, so I just wrote down, you divide by 4. There's my 4's out front. In my parentheses is x squared minus 6x plus 9. Now, anyone notice anything in this particular case? Bigger? Okay. Do I still have an a value in front of x squared? No, I'm back to just having 1x squared, which means this goes back to the form at the beginning of the lesson of 1x squared plus bx plus c. So there's 2 different ways we can actually do this problem. Do I have to do product of AC here? No. Okay, now, can you do product of AC? Yes, you can do product of AC. To me, it's a little longer and thus unnecessary. But if you don't catch it, you don't have to use product of AC. By all means, do product of AC, you'll be fine. But here's what I'm going to do. I'm going to say, forget product of AC, and I'm just going to go product and sum. Meaning what I know right now is that my 4 will carry down, and then assuming this factors, which obviously I've indicated it is, I'm going to have a 4 and 2 parentheses. Because what does x squared break into? X times x. So, how do I find those numbers? Okay, product of 9, a sum of negative 6. And notice when you go to do product of AC, you'll be like, oh, a is 1. And so it's still product of 9, sum of negative 6. What multiplies to be 9 and adds to be negative 6? Okay, it's a combo of negative 3 and negative 3. So what goes in my parentheses? Minus 3, minus 3. Okay, now, I personally would accept this answer. I never remember about Math Excel. There's another way you can write this answer that's a little clearer though. You know what it is?
4 times 1
No.
x minus 3 minus
1 third.
4x minus, no, it's 4 times.
What do you think, Jacob?
It's one of the parentheses has
Okay, he said has a 2 at the top, meaning there's an exponent of 2. So the 4 stays out front. X minus 3 times x minus 3 is the same thing as saying x minus 3 quantity squared. So your best form is 4 times x minus 3 quantity squared. Now, I said that these were perfect, or excuse me, I said these were special cases, right? If we had any that end up like this with x minus 3 quantity squared, where parentheses end up identical, and we have not. These are what are called, and I say these because it applies to F2, perfect square trinomials. Okay, so E and F are what we call perfect square trinomials. When we talk about a perfect square trinomial, it means that when you factor it, it factors into 2 identical parentheses. So it's a perfect square trinomial. Now, it also means if you recognize something as a perfect square trinomial, there's a shortcut you can take. And that's what I want to show you on F. On F, you can use product of AC, and you can leave it in the end, and it will work if you don't want to hear what I have to say. But I also want to show you a shortcut that can work on F. Okay, so, same old first question is there a GCF? Is there GCF on F? My last number is a 1. Only thing in common could be a 1. Okay, so no GCF other than 1. Now, here's what I'm noticing. Okay, so I could do product of AC. So it'd be a product of 64 times 1 and a sum of negative 60. And I can go that whole process out. It's not bad. But here's the other thing. 64x squared. 64 is a perfect square, meaning I can what? I can square root it, yes. Okay, so this first term is a perfect square. I can square root it. What about 1? Can I square root 1? Think again. What times itself is 1? The square root of 1 is 1. Okay, when you run into a situation where your A values and C values are perfect squares, it is possible that this is a perfect square trinomial. That's what happened over here. X squared is a perfect square. You take the square root of x squared, 1x squared, and 9 is a perfect square. So here's what you check. First of all, what would be the square root of 64x squared? If we want to get technical, yes, 8x, right? Because it would be 8x quantity squared, right? So that is a perfect square. Check your C value. What about 1? Can we take the square root of 1? Yeah, the square root of 1 is 1. So both of those have perfect squares. Now, you can't just assume that it works because A and C have square roots. You have to check that middle term. And here's how you check the middle term. If this is true, the middle term is 2 times the square root of the A value times the square root of the C value. If this works. So that means, okay, so 2, what was the square root of my A value? 8 or 8x, right? What was the square root of my C value? 1. Does 2 times 8x times 1 result in 16x? It does. So this is confirmation that it's a perfect square trinomial. Okay, perfect square trinomial. What this means when I write my answer is that, first of all, my final answer is going to be
Something times parentheses squared.
a parentheses squared. Or you can think of it like this. You can think of it as parentheses times parentheses. But here's what you do. Okay, what was the square root of 64x squared? 8x. So what goes in the front of each parentheses? 8x. C value. What was the square root of 1? 1. So what goes in the back of each parentheses? 1. Okay, sign-wise. These, we multiplied, if you go back to your product and sum type idea, it multiplies to be a positive and adds to be a negative. When we multiply to be a positive, your two signs are the same. If it adds to be a negative, they are both negatives. So basically, oops, you can't see what I have written on the far side there. Basically, the shortcut that I'm saying is these two signs are the same as this middle sign here. Okay, the last sign will always be a plus in this situation, like it's a plus C value. But your sign here, parentheses, always match your B value. So my final answer is 8x minus 1 quantity squared. Now, for those of you questioning, I don't believe that works with the sergeant. How do you check yourself? Boil it back together. Or try product of AC. If I pull this back together, 8x times 8x, 64x squared. Outsides, 8x times minus 1. Negative 8x. Insides, negative 1 times 8x. Negative 8x, negative 8x, and negative 8x. Negative 16x. And last, negative 1 times negative 1. Positive 1. It works. Yes.
So what is a perfect square trinomial? You don't have to do that.
Like product of AC.
Like the you don't have to do the
Okay, so the slight difference between E and F is that once I got my GCF out here, I had a 1 up front. And so you can't do it exactly like E. You'd have to go back and more do it like A, B, C, or D, where you'd have to do product of AC all the way out. But yes, you can do product of AC. Okay? Here's the deal. When you get into these perfect square trinomials, they sometimes give you bigger numbers. And so if you can catch that's a perfect square trinomial, they'll make the math a little bit easier. If you don't catch it's a perfect square trinomial, it's not the end of the world, though. That's my point.